Okay, so welcome to the lecture 4 of our series Introduction to Labview. Today we are going to start with the another structure that is known as the for loop. Now we have seen that how while loop works in a Labview, what are the characteristics of while loop in a Labview, how the data is entered in a while loop, how to data is extract from a while loop. Now we will move to the next part, that is for loop. Now for loop, how the for loop can be accessed in a Labview. You can go to the function palette on the structure, then the first option will be the for loop. Now this is the structure of the for loop. You see, if you compare the for loop with the while loop, you see in a while loop we have a loop condition. But since for loop has been used for when we know that how many times I have to run a particular loop, so I already know the iteration rate. So in for loop we need a iteration number. So this is our iteration number. You need to give the loop count, how many times you want to run a loop. And similarly, when in a while loop, the loop terminal is a very So welcome to the lecture 4 of the series Introduction to Labview. Today we will start our new topic, that is Introduction to for loop and the shift registers. Now in previous lecture we have gone through the while loop introduction. Now what is while loop, how the while loop work, how you enter the data inside a while loop, how you can extract the data from a while loop. Now today we will start with the introduction to for loop. Now for loop has been very much important in when you want to create a virtual data set, when you are dealing with the array of data. The very important functions in a while loop is for loop. Now if you compare the for loop structure with the while loop, you see the for loop is exactly somehow different from a while loop, but there are some things that are similar, which is one is the loop iteration. Another is you can add a stop terminal here also, but you need to add it by right clicking on the border, and you can just add a here you can add a condition terminal. Okay, so this is a condition terminal you can add in a for loop also, and you can remove it, but you can't do that in a while loop. So like in a while loop, how you can access a for loop in Labview, you have to go to the function palette, then structure. The first function will be the for loop. Okay, you just grab it and drop it here. Now likewise in a while loop we have a loop condition. Okay, in for loop we have the number of iteration, that is loop count. I need to give the loop count. So it will show error until unless I will put some value here. So suppose I will put 10 here. So that means it will run 10 times. But what should be the loop iteration? It will start from 0. Likewise in a while loop also, you see it has been start from 0, and it will go up to 9. So it will go up to n-1. So 0 to n-1. The range of the I, it's 0 to n-1. So if you see, if I run it, you see the value is 9. So again it is start from 0. So what you can do, you can just put it one increment and just take out the value if you want to know exact number of times the for loop runs. Now for loop is a very important factors that it has been used to create a virtual data. So suppose I want to create a sensor data whose range is from 0 to 25, and a number of samples I need to take out is 10. So what I can do, I can just keep out the data from and I just put it at the border. Now this is very interesting. I already told you in a while loop, the tunnel mode, that we have 2, that is the last value, which is the value like on the last iteration, and indexing means all the values at each iteration will be taken outside the loop. So in for loop, by default we have indexing present, so it is known as auto indexing. So auto indexing means that whenever I take out the data outside the for loop, it will came out in a array format, that all the data at each iteration rate. So suppose if I want to know the data, I just run it and I know that this is the 10 data available. So if you want to know the size, you can know the size of this array and create indicator. So this is 10, the size is 10. Okay, so this is one very important factors in a for loop. But wait, for loop is not just that simple. Okay, so if I put a for loop, now I told you that for loop will work when we have a value of n. Okay, now suppose if I don't have I don't want to put a value of n inside. Control Z. Now, if I want to, I have one array. I need to create an array constant. I have created one array constant here. Sorry, not the enum. And I take out some value like 1, 2, 3, 4, and 5. And I just put these array constant at the boundary, at the output boundary of a for loop. Now tell me how many times my loop run. So suppose I will have here create indicator, the loop count. This is a loop number, loop iteration. Let's say the loop iteration. So I need to add one. Huh? Now if I run it, you see my loop will have run only 5 times. Why has that happened? Now, because in a for loop, you can access a data one by one using an array. So what if you have connected an array, what it do? It will give out the value one by one. It will take out the value one by one from an array inside a for loop. So suppose if I have an indicator here, just say this is an array elements, and if I run it, you can see by your eyes that okay, let's just use a timing, otherwise you can't see it. Okay, so if I run it, you see one by one my array element has been came like 1, 2, 3. So they came inside a for loop one by one, just like they were taken outside the for loop one by one. So this is a very important factor. Now suppose if I put it 2, then what the value they will take? The for loop will take, it will take the minimum value, whichever the minimum. If you have connected both, like you have given the value of n, also you have connected an array also from outside, then it will take whichever the minimum. If the size of an array is minimum, it will take that size as the loop count, and if the value of n is minimum, it will take the loop count, the value of n as a loop count. Now if both are available, if n is not available, it is not necessary when you have connected an array from outside to give out the value of n. In that condition, it will take the size of an array as the loop count. Okay. So it will start, and whenever I put it, whenever I run it, I will take the value, whatever the value it has. You see the size now become 5. Now this is a one part. Now suppose I need a 2D array format. Okay, so for 2D array, what I do, I have used another for loop from outside. Now I just delete this, Control B, and I have connected some value here 4 and some value here like 3. Now at first iteration, that the outer loop, suppose this is an outer loop, let's just write it as an outer loop. And this is a inner loop. Okay. So this is an outer loop and this is an inner loop. So for first iteration of an outer loop, the inner loop will run 4 times. Okay. So it will run 4 times, mean if you calculate the number of elements in an array, you can have like 4 into 3, like 12 items. But how the array behaves, whether we have an array in a single dimension, whether we have an array in a 2 dimension, what should be the dimension of an array? For that you have a tunnel mode again. Now first is when you have a auto indexing on, what it can do, what nested for loop will do, it will increases the dimension of an array. So if I created an index, this is loop 1 data, or you can say inner loop data. This is outer loop data. Okay, so both I have here. You see the outer loop has been in a 2D format. You see, I already told you what are the formats of the array, and this is the inner loop. This is the size of inner loop. Okay, now whenever I run it, okay, it will take time. But you see all the elements, and the last row will be same as the values of inner loop data. So the last row will be like same. So first I have to remove this timer. So you see outer loop has 2 dimension, and it will contain all the data that has been the number of times the inner loop has been run. All the data has been available. Now this is 2D. If you want to increase again the size, you need to put another for loop outside. Now further, the most important thing, that which will justify, which will decide the number of, which loop will decide the number of row, and which loop will decide the number of columns. Now inner loop will decide the number of columns always. The innermost loop will decide the number of column always, and column will be given here. If you have 2D array, then the bottomest, the most bottom index will show you the index of column. So you see, if I change the column, number of columns, then I can only see up to that. It will show the column from index 2 only. So from 0 it has shown all the values, and this is for the rows. The uppermost is for the row. If I have another loop that I have a 3 dimension, then the uppermost will show the sheet number, and just below it will show the number of rows, and just below it will show the number of columns. So this is the nested for loop has been very important. Similarly, if you want to reduce the size of an array, you can again use a for loop here. Like suppose I have taken a for loop first. So it will take out the data row wise inside a for loop, and I have connected here. Suppose the best way to connect is from the input side. It will not take the there is no necessary to take the n value, and I can get a indicator here. Now you see the size has been changed here, and if I again take out another loop, then this size again reduces to a single scalar element. Okay, so you can see create indicator. Now this is a single scalar element. So this is a beauty of for loop in Labview. Okay, so this is very important things to understand, that how we can create an array in a for loop. Now the third thing we have come across, like indexing and last value control set. Okay, control B for removing the broken wire, you can use control B. Now suppose I don't want to increase the dimension of an array. I just need to I just need all the data in just one D array. So for that, what we can do, we can go to the tunnel mode, we can start and concatenating. Now concatenating means what? You have an indicator in which all the data came in 1D format only. The size of an array the dimension of an array has not been changed. Size has been changed. The dimension will not be changed. And if you see the size, it will came out the number of element, that is 12. So if I run it, you see the size is 12. Okay. So this is one part, and another is, suppose now if I have some problem and I want that whatever the range is increases to 50, the sensor, the atmospheric range has been increases to 50, and I want to say that whenever it crosses the 30, you should not have the value. Okay, will not take the value until and unless it is greater than 30. Okay, so whatever the value is greater than 30, I only take that value. So what do you do during the auto indexing in a tunnel mode? You can on the condition terminal. Okay, now what the conditional terminal do while taking out the data outside the for loop? It will follow that condition. So suppose if I say that the data only which is greater than 30 will be taken out the for loop, what I can do, I can just use for taking out the data, I select that it should be like auto indexing mode, and with that I add the conditions. Now what is the condition? That the data should be greater than 30. So only data that is greater than 30 will be outside the only that data will go outside the for loop. So if I run it, you see only the data that is 49, only the 49 is the data which is greater than 30. All the data is less than 30. Now I should change the range so that you can get more number. So if I run it, you see these are the data: 39, 34, 33, 44, 38, 40, 44, 35. Now this is the data. This is the only data which has been coming out from the which is greater than 30. If you want to see the original data, just taken out at some other border at the border, and you just take a value, and this is the original data. Okay, I should choose it outside here. Okay, not here. Put it here, and need a concatenating. Okay, so tunnel mode, and here concatenate this. Okay, this is the original data. We can see the original data also and the modified data also. So if I run it, you see this is the data. This is the whole data, and this is the only data which is greater than 30. So you see, you can do very much, in fact, all the programming in a for loop mostly, which you have done in what we can have normal text-based language like C or Python. Now we will move to next part. Suppose let's start one simple problem like if I want only the odd number will be even, or you can have in a given data set you need to separate the even and odd number. So what I can do, I'll take a for loop. I take a random number generator. I only take U30, U64. So suppose from 0 to 50 range I need to change. So 0 to 50 range, and I will create a constant like I only want 10 samples, or you can have 15 samples. Okay. And what I do, I have to, because if I want to know that whether a number is even and odd, it should be divided by what? It should be divided by 2. And if it should be divided by the number which has remainder equals to 0, then it is a even number. So I put it, and while putting it here, I open the tunnel mode and I add the condition, and which is equals to 0, and whichever not equals to 0, I put another value, and for that I use a not gate, which is not equals to 0. If it is not equals to 0, add a condition terminal here. And this is an create indicator. This is even part, and this is the odd part. Okay, so if I run it, my even and odd has been separated, you see. So this is my even part and this is my odd part. So this is very easy in Labview as compared to the text-based language. Obviously, those who have fluency, they don't need any extra task, but those who are new to programming, I think for them it is so easy as compared to the text-based programming. You don't need to remember anything, you just need a concept. Now we will move to the next part, that is the introduction to the shift register. Now shift registers are very important. Okay, so let's just start in a quick way that how to introduce a shift register. Shift registers can be used in a while loop also. You can access them in a while loop and for loop. So only in loops you can access the shift register. So how to introduce a shift register? You just right click on the border. There's an option came add a shift register. First you need to initialize a shift register. So for example, it can be anything. You can have a Boolean shift register, you can have a string value, you can have a numeric. I take a numeric value, and suppose I need to create a count. For example, by one everything will be adding. I need a count, so or I need I need a suppose table. I need to create a table. So for example, 2 into 1, 2 into for a number, create a table for a number. Whatever value you have, this is a previous terminal and this is a current terminal. In a previous terminal, you can have multiple previous terminal. Like for example, if this is a n value, this is n plus 1. Now this is n minus 1, n minus 2, up to whatever the time you need to show. But how many times you open the previous value, you need to initialize each value. Okay, each shift register. So I need to initialize each shift register. Now I have given the value. I want like a loop count, suppose 10, and I need to add the consecutive numbers. I need to add them, and I need to just give now this value, give some value extra to this number. So suppose I've given this 1 and this is 0, or put this 1 and this is 0, and now this will only take out a single value because the current shift register will only contain one single value. But if you want to take out all the data, you can have this indexing and you can create a number. You can Control Z. You can have an indicator here, and if you see, if you run the program, okay, I don't need that. You see, I got the number. Okay, so I have not take this. I should take this. It will be like, you see, this is a Fibonacci series. Okay, so I can make a Fibonacci series using a for loop and using a shift register, or you can check whether a number is palindrome or not. You can have you can have a factorial numbers also. Suppose I want to know the factorials, you can have a factorial also. So for that, suppose this is the for loop, I need a factorial of 5, or you need a factorial of whatever the value you can have that factorial. And we can have like, suppose I want a factorial of 5. Okay, so I need to initialize a register, I need to create a constant, take a constant, we'll start from 1. And how many times, suppose whatever the factorial number you want, you can put it here. Suppose I put 5. So 1 into 1, then into 2, whatever the value. So you can have multiply here the values. So 1, then you need to add some value here, increment by incrementing. Okay. So Control P, 1 cross 1. You can have this number. Create indicator. The last, if you want only the last value, you can have here also only the answer. Okay, so this is the final answer. If you run it, so it is 20. You can have this control, change to control. Okay, this is number or factorial. So suppose if I want to have a 6, I want to know the factorial of 6, I can run it. 4, I can run it. So these are the different kind of what we can say, these are the different kind of things you can have in Labview, like using a shift register. So shift registers have been like a loop. It will create something loop kind of thing inside a loop, so that you can access any previous data while the loop is running, because we can't access data while the loop has been run. We can only access the data after loop stopped, or whether it is a for loop, whether it is a while loop, you can only access the data, you can only take out the data outside only when the loop has been stopped, but not during the loop running condition. So to access the data during the loop running condition, you can use a shift register. So shift registers play a very important role. They can have a memories, they can store a data for a particular time period, obviously. But this is a very important aspect when you have a when you were dealing in a Labview and you need some kind of simple programs like using a finding a factorial, creating a Fibonacci series and something like that. So this is all can be done using a for loop and a shift registers. Now if you want, we can have one more problem, that is checking whether a number is palindrome or not. For that you can have like a for loop, and for the number also you need what you can have, because I want the number of times the number can run. Suppose I have taken a number to check. So first I need to convert it in a string. This is a number to string converter, and this is percentage %d means I only take a integer value. So now it will convert me my number into a string, but I don't need a string number, I just need its length for given to n. Okay, now let's start with checking a number. So I'll take a number and I just we can divide it, multiple division. Okay, so the best function is use this, and we can have a multiple division here. First I need to replace it with a shift register. Okay, and I'll create a constant, I'll divide it by 10. So at each value the quotient will be given to the loop condition, and this remainder will be my digits. So whatever the value we have, it will convert it. Okay, you can see it, create indicator. This is the digits of the number. Suppose I have given out the number 1 2 3 4 5. Okay, and if I run it, all the number I can have here. Now I have a function known as reverse array. Okay, reversing an array. Yeah, so I can reverse it, and then I can have use a comparison equal to. Now there are many ways that I have taken a number in which some digits can match, but all digits cannot be matched. So the output of this comparator equal to will be a Boolean array. So I need when all the numbers matches, then only the number is palindrome. So I'll use a or and an array element. I'll need the ending operation on all the array elements, and only then if it is 1, then my number is palindrome. After that I use one very important function, that is a select switch. In select switch you can have 3 terminals, input terminals, in which the middle one will, depending upon the condition, it will take a value, the upper value on the lower value. So if it is true, then the number is palindrome. And if it is not true, the number is not. Okay, and create indicator. This is the message. Okay, if I run it, you see this is the message, and if I run it, then this number is not palindrome. But if I use the number this, then this number is palindrome. So thank you for today. This is all I think we completed somehow the basic of the Labview. In the next section, we will see the hardware section, like using the DAC, NI DAC cards, and accessing how to acquire data in a real time using a data acquisition cards. So thank you so much for